We are at the Chemical Engineering Teaching Lab, and as a chemical engineer myself and with a specialization in process engineering, I'm really excited to show you around this lab where we provide hands-on experimenting for first year students to understand more about what it's like to be a chemical engineer. This is where I also did my first product, which is a fermentation project where we created an alcohol-based fruit product. So with me, I have Dr. Karthiga Nagarajan, who will show us around the lab and the different features that it has.
Thank you, Shruti. Hi everyone, I'm Karthiga. I'm from the Department of Chemical and Biomolecular Engineering. I've been teaching core chemical engineering courses, and the course Chemical Engineering Principles and Practice 2 is one of my favorite, and you will know why in a short while. So Shruti, this is our department's biomolecular cluster. So it caters to the needs, our department's research and as well as teaching needs. But today what I'm going to show you is typically the facilities, the biomolecular facilities that is specially curated for our year 1 students.
So Prof, could you tell us more about the role that this teaching lab has on the chemical engineering curriculum and what can students expect to learn?
Okay, so you know that chemical engineers typically explore how we can actually convert readily and cheap raw materials into useful products that enhances the quality of life. But this conversion does not happen in a single step, right? There are several sequence of steps. So if I were to design a process, that means I need a strong foundations in chemical engineering principles. So what we do here in this year 1 laboratory is we introduce to students the foundational principles of chemical engineering through hands-on experiments actually. But to add on another layer, typically there is a common idea that chemical engineering principles are applicable for a chemical process industry or even for a petrochemical industry for that matter. But we want to emphasize the fact that chemical engineering principles has a practical relevance in a biologics manufacturing plant. So typically in this lab, students come here, they learn, they observe the chemical engineering principles in action with respect to bioprocess related experiments.
So one of the highlights of the chemical engineering program is clearly the fermentation project. So could you tell us more about how students apply their knowledge in this project?
So regarding this fermentation project, it is actually a design project in this course. Students usually do it in the later half of their semester. So let me just give you a background on how students apply their knowledge, how they apply their knowledge. To begin with, right, in the very first few weeks of the laboratory session, we introduce students on how to handle microorganisms in the first place. So typically students use this biological safety cabinet and they handle the microorganisms inside the BSc. And then later on they understand what are the different types of growth medium available, how to pre-treat the growth medium, and then they learn how to grow cells on a lab scale, like using a Shaker's incubator. During this particular studio, they understand what are the various factors affect the growth of cells. And they use the data to do a cell growth kinetics as well. Okay, Shruti, a quick question. Do you know what is this equipment and what is it for?
Of course, Prof, it was taught by you, so definitely I remember. This is a UV spectrometer and is used to quantify cells.
Okay, so we quantify the cells as they grow in the bioreactor and we model them. Students later then learn how to separate and purify the products coming out of a bioreactor. And through these learnings in the initial few weeks, they apply it to pursue their design project. So if you recall, right, the objective of the design project was to produce novel, high quality alcohol using fruits or vegetables simply by yeast fermentation. And over every academic semester, what we do is we change the design constraints. So students have a little bit of flexibility and they can choose which products that they want to buy. Say for instance, in one of the academic year, we ask students to use tropical fruits like mangoes and pineapples to produce the alcohol. And in another academic semester, we ask students to use grains to produce the alcohol. So typically during the design project week, the lab smells really wonderful. Students bring in these products, they process it in the lab, and then they do the fermentation, anaerobic fermentation. After 2 weeks, they characterize the product, right? And yours did meet the requirement, isn't it?
It
almost met the requirement. And of course, they compile all these findings in the form of a poster. And the poster day is the highlight of our course itself.
We are very fortunate to have access to very advanced equipment like this in-house built bioreactor. So Prof, how does this in-house built bioreactor teach students more about bioprocesses and its real-world application?
This bioreactor setup is used in the production scale-up studio. So basically in this studio what students do is they actually build and assemble the various components in a bioreactor along with the instrumentation, and they operate the bioreactor to reach a target yield. So the design of this bioreactor setup, right, it simply mimics the commercial ones that is available. Let me show you the commercial one here. So here we have the commercial bioreactor with the control system. You can clearly see that in this bioreactor setup there are various ports for adding in cells, for adding in nutrients, for measuring pH, temperature, dissolved oxygen, and we also have ports for stabilizing the pH of the system as well. And this particular bioreactor is connected to a control system, and this control system, in this system you can actually key in your operating parameters like what is your temperature, pH that has to be maintained. So once you start with your bioreactor operation, the system will measure the parameters and adjust the cell growth conditions. So with this thought process in mind, we actually designed the in-house bioreactor setup. So here Shruti, we have our in-house bioreactor. You can certainly see the striking resemblance between these two setups, right? So typically what happens in the studio is we provide the students with an objective of the target yield of cells. Now students has to decide based on their past learnings how they want to operate this bioreactor, what type of cell growth conditions they have to decide. Once they have decided upon it, they assemble the bioreactor components including the various instrumentation, they connect them to the control box, and then they start the operation. And they can continuously monitor the growth of cells and monitor the growth parameters as well. Eventually all this data is actually compiled and the students analyze this data and check whether they have achieved the target yield or not. I trust you did achieve the target yield, right?
Yes, we did. So Prof, what would you say is an extra element in these studio sessions that equip students with future-ready skills?
In addition to introducing the foundational principles of chemical engineering, if you notice, in every studio session, student does hands-on experiments. So students learn how to conduct an experiment based on an objective. They know how to collect data, analyze the data, critically analyze it, and then compile it in the form of a written report. Okay, so that covers the written communication part. And of course, you might remember that every studio session, we have something called as a chalk and talk, right? It is a quick 5-minute presentation and the topics varies every week and it is based on the theme of that week's studio. So this short 5-minute presentation actually prepares students on how they can actually summarize a certain piece of intense topic in a very impactful way. And I trust these two components on the presentation part will definitely help students very much in the future. And adding on further, if you notice all our studio sessions, we did it in the form of groups of 5 or 6 members. So the idea behind having students working in group of 5 or 6 members is you understand each and everyone's strength and weakness and you learn from your peers. That actually enhances your teamwork skills as well.
That's exactly right. Thank you, Prof. Thank you, Dr. Karthiga, for this very insightful tour of this chemical engineering technical lab. I must say that this hands-on experience has been very impactful in my journey of being a chemical engineer, and I hope this made you understand what it's really like to study chemical engineering in CDE. With that, we've come to the end, and thank you so much for listening. Bye-bye.
Thank you.